It wouldn't come with fire or thunder, just silence as space itself began to fold. Tonight, somewhere in the dark, a rogue black hole drifts closer. Unseen, unstoppable, a shadow not of death, but of the universe remembering us. Asterisk, it begins with silence. Not the silence of a room, nor the silence between words, but the silence that lives beneath the universe. A stillness so vast it swallows every heartbeat, every sound, every thought. Then a whisper, not of wind, nor of life, but of gravity. The faintest tremor in the fabric of space-time itself. In 1915, deep inside the labyrinth of his equations, Albert Einstein glimpsed something no human mind was meant to see. A place where space collapsed under its own weight. A point where time would twist upon itself until meaning dissolved. He didn't call it a black hole. He called it impossible. And yet, a year later, from the mud-soaked trenches of the First World War, a German soldier named Karl Schwarzschild would send Einstein a letter. Inside it lay a perfect solution, a mathematical shape where Einstein's equations no longer broke, but folded inward infinitely. In the middle of chaos and death, Schwarzschild had discovered a new kind of silence, one so complete, not even light could escape it. Weeks later, he would die of illness, but his solution would outlive him by billions of years. For decades, this idea was exiled to the margins of physics, a curiosity too strange to be real, a ghost in the mathematics of relativity. The world moved on, building telescopes, splitting atoms, dreaming of rockets. But the whisper waited. Then, in the 1960s, radio telescopes caught something that refused to fit the map of the known. A point in the constellation of Cygnus, emitting X-rays with impossible intensity. Cygnus X1, invisible, powerful, hungry, a star's light being devoured by something unseen. It was the first clue that the ghosts were real. Astronomers began to find more stars orbiting emptiness, light bending without cause. It was as though the universe itself was haunted. Every time they looked deeper, they saw light curve and vanish where no object could be seen. Something massive, invisible, was pulling at the threads of space. But there was one kind of black hole no one wanted to find. One without a home. Not bound to a galaxy, not caged by a companion star. A rogue, set adrift by the violence of creation itself. When a massive star explodes asymmetrically, violently, the blast can hurl its collapsed core free from its birthplace. What remains is a singularity, cast loose into the cosmic sea. No orbit, no anchor, just an eternal traveler, moving through the dark at hundreds of kilometers per second. 1,000,000 years could pass, and it would still drift, unseen. It emits no light, no heat, no warning. Only its gravity betrays it, a pull strong enough to warp the motion of distant stars. In 2022, after decades of searching, that whisper finally grew loud enough to hear. NASA's Hubble Space Telescope recorded a strange distortion in the light of a star, nearly 20,000 light-years away. For weeks, the star brightened, as though magnified by an invisible lens, then dimmed again. Gravitational microlensing, the fingerprint of an unseen object bending the path of light itself. It was the first confirmed detection of a free-floating black hole. For astronomers, it was a moment of revelation and unease. Because if one could be found in so small a patch of sky, how many more drift unseen? Models now suggest there may be 100 million rogue black holes wandering our galaxy, each one a silent predator, the corpse of a long-dead star, carrying the memory of light that once was. They travel between the arms of the Milky Way like seeds of gravity, eternal and aimless. Some are small, just a few solar masses. Others, perhaps, are ancient behemoths, relics from the earliest stars when the universe was still young and raw. They move without pattern, without intent, obeying only the deep geometry of space-time. Their paths are random, their presence invisible, their destiny inevitable. And if one of them were to pass near our solar system, it would announce itself not with light, but with the slow bending of the heavens. Stars would begin to drift in ways our maps could not explain. The outer planets might tremble, the Oort cloud would shiver, and we would have no warning, no defense, no time. Somewhere in the galaxy tonight, such an object drifts between the stars. Cold as death, older than memory. It doesn't know we exist. It doesn't need to, because to the black hole, all matter, all light, all time is equal. The whisper is still out there, and one day it will find something else to listen to. Perhaps a star, perhaps a world, perhaps us. The universe does not scream when it ends something. It only folds its silence a little tighter and waits. It begins not with thunder, not with fire nor light, but with something so faint, so ordinary, that no one would notice. A flicker in the pattern of the stars. A single star's brightness shifts, not by much, only a fraction of a percent. Then another nearby star follows, and another. To the naked eye, the sky remains unchanged, eternal, still, absolute. But in the cold precision of observatories orbiting above the Earth, a pattern begins to move across the constellations. A slow, creeping distortion, bending the light of distant suns. At first, the data seem trivial, an anomaly, perhaps an instrument glitch. But when teams from Chile, Hawaii, and space-based observatories compare results, the truth sharpens like a blade. The pattern is moving. Something invisible is gliding between us and the stars. Something with mass. Something powerful enough to twist the geometry of light itself. The first whispers come from Gaia's deep sky archive, millions of precise stellar positions measured with impossible accuracy. One cluster in Sagittarius shows irregular deviations, a curvature in motion, as if the very backdrop of the galaxy is bending. For months, astronomers model and remap, subtracting every known cause, exoplanets, binary companions, cosmic dust, even instrumental noise. Nothing fits, until a young researcher, lost in her night shift calculations, runs a microlensing model, and the simulation overlays perfectly. The conclusion freezes her. The pattern is consistent with a black hole, and not one bound to any system. It is moving. At first, disbelief spreads faster than the discovery. A rogue black hole passing through our local star field. Impossible. Black holes belong to galactic centers, colossal anchors around which everything orbits, or they exist in pairs, locked in gravitational embrace. The idea of one drifting freely near our solar neighborhood feels absurd. The astrophysical equivalent of finding a shark in the desert. But probability, as always, bows before scale. In a galaxy with 100 million black holes, even the improbable becomes inevitable. Given enough time, the world's major observatories turn their eyes toward the anomaly. The James Webb Space Telescope, with its cold mirrors tuned to the faintest whispers of infrared light, joins the watch. The pattern strengthens. the distortion moves with measurable velocity, and with each recalculated orbit, its trajectory inches closer to home. What follows is the kind of quiet panic only scientists know, not the fear of monsters, but of mathematics. Because gravity, when written into equations, leaves no room for mercy. A black hole does not need to touch a planet to unmake it. Its reach is infinite, its influence subtle but catastrophic. A massive enough object, passing within a few light years, could warp the balance of the solar system itself. Planetary orbits, the grand clockwork of cosmic time, could drift out of sync. A tilt of mere fractions of a degree, and seasons would collapse. A slight perturbation to Jupiter's path, and the architecture of our celestial order could crumble like a delicate machine nudged from equilibrium. Beyond Neptune lies the Oort cloud, a halo of icy debris encasing the solar system, the graveyard of its birth. A passing gravitational tide could disturb that frozen sphere, sending a storm of comets inward, a cosmic rain that might last centuries, each one a silent missile, ancient and precise, guided by nothing but fate. In conference rooms across the planet, the data are reviewed in reverent disbelief. The object's mass estimates vary 5, maybe 10 times the sun's weight. No radiation, no accretion disk, no light. Only the bending of the stars betrays its existence. Governments remain silent. There are no press releases, no headlines, just equations. And every equation leads to the same conclusion: a gravitational anomaly moving roughly toward our region of space. Not tomorrow, not next century, but close enough for its influence to already be measurable. Astronomers, trained to separate emotion from observation, begin to feel the cold press of something older than fear. Cognitive dissonance blooms because this shouldn't be happening. The mathematics of celestial motion, the vast stability of orbital dynamics, has been our civilization's quiet comfort. We believed in the order of the heavens, a cosmic architecture that would hold steady beyond human time. But that faith falters when the universe reminds us that it is not stable. It only appears so for a while. The paradox deepens. The laws of motion are immutable, yet within them, chaos hides patiently. Gravity follows rules, but its consequences are wild. Every star, every world, every atom is playing in a dance choreographed by inevitability. And sometimes, that inevitability drifts close enough to feel. The teams at ESA and NASA cross-check again. They calculate the object's motion relative to the galactic plane. They factor in solar velocity, interstellar drag, even hypothetical dark matter interactions. Every refinement tightens the estimate. Its vector aims not at Earth directly, but near enough for the solar system to tremble. It could pass within 3 to 5 light, close enough for the Oort cloud to awaken, close enough for the planetary orbits to begin their subtle decay, close enough for the tides of space-time itself to start whispering in our direction. The realization strikes, like quiet lightning. Near, in cosmic terms, does not mean touching. It means influence. It means inevitability, unfolding slowly across centuries. It means the first changes may already have begun. Somewhere, in the endless dark between the stars, the rogue black hole drifts without aim, without sound, without light. Its gravitational fingers reach invisibly across the void, brushing against our solar system's edge. And as it moves, the sky itself begins to bend. Ever so slightly, a soft shiver running through the constellations. For the first time, the human species stares not at an alien, a weapon, or a god, but at gravity itself, alive and moving toward us. The stars do not scream. They only shift, and the universe, patient and unblinking, watches itself begin to change. It begins with a pattern, faint, deliberate, and impossible to ignore. In the darkness between stars, the light itself begins to lie at the edge of human perception. Telescopes stare upward, capturing the smallest distortions, shifts so delicate they would vanish inside noise, if not for the persistence of those who listen to silence for a living dot in a high-security control room. Deep within NASA's Jet Propulsion Laboratory, a team watches their screens flicker with Gaia's newest data release, Doctor 3, the most complete stellar map humanity has ever built. Over 1 billion stars, each with coordinates more precise than the width of a human hair measured from thousands of light years away. But precision, in the hands of gravity, becomes prophecy. When the astronomers overlay new readings with older baselines, they find a disturbance, a faint, mobile warp moving through the map like a ripple in glass, a shifting lens distorting everything behind it. At first, they suspect error, a calibration issue, but the same distortion appears again in Pan-STARRS optical surveys from Hawaii, and again in the Vera Rubin Observatory's first deep sky test mosaics. Different instruments, different hemispheres, same anomaly, same motion, so they call in others from ESA, from Ligo Virgo, from observatories that measure not light but space-time itself. Together, they form what journalists will later call the Gravity Network, a coalition built not on borders, but on the shared fear of what their data is whispering. And as the data converges, the image sharpens, a rogue black hole, solitary and silent, crossing the galactic neighborhood, its path angling dangerously close to the solar system's outer rim. But to understand what they are seeing, they must first understand how they are seeing it. Gravity bends light, not metaphorically, not figuratively, but literally. Einstein had predicted it more than a century earlier, that mass warps space-time, and light, obedient to geometry, must follow that curve. When a massive object drifts in front of a distant star, it bends and magnifies the starlight behind it, creating a fleeting illusion, a perfect circle of brightness called an Einstein ring. To the human eye, it's invisible, but to instruments tuned with obsessive precision, it's the voice of gravity speaking in the only language it knows. Distortion, this is gravitational microlensing, the signature of an invisible giant moving across the void. The rogue black hole reveals itself not by light it emits, but by the light it steals and reshapes, like a cosmic magnifying glass. It sweeps through the star field, amplifying, stretching, then releasing each star's glow in a pattern as distinct as a fingerprint. The Rubin Observatory's massive 3.2 gigapixel camera begins to trace these changes frame by frame, night after night. The lensing pattern shifts westward, slow but deliberate. Triangulation across multiple instruments refines the trajectory, not a random drift, but a path arcing gently toward the sun's gravitational sphere. Meanwhile, on the computational frontier, supercomputers at NASA's Ames Research Center ignite. Hundreds of processors simulate the gravitational ballet of the solar system under the intrusion of an external mass 10 times heavier than the sun. They run models, spanning centuries, compressing eons into minutes. On their screens, orbits wobble. Jupiter's path deviates by microseconds, a displacement smaller than thought possible to detect. But it's there, tiny, deliberate, irreversible. Planetary scientists, at first skeptical, confirm that the data aligns. Something unseen is already tugging, ever so gently, at the solar system's spine. And with each recalculated simulation, the same conclusion returns. The object's projected path slices through the outer heliosphere, the sun's distant bubble of influence, but the universe rarely reveals a single clue at a time. As astronomers chase optical ghosts, astrophysicists listen for whispers in higher frequencies. When a black hole grazes through interstellar dust or swallows even a handful of rogue particles, it releases faint X-rays, the dying screams of matter pulled beyond salvation. Space telescopes like Chandra and XMM Newton begin to detect such signals, soft bursts with no known origin, flickering faintly in the direction of the suspected path. It's confirmation enough. The invisible has found a voice, and then another voice joins. Not light this time, but time itself. Across the galaxy, pulsars spinning neutron stars that flash with the precision of cosmic clocks begin to stutter. Their signals, once consistent to the microsecond, arrive offbeat. Not much, a fraction of a tick. But across thousands of parsecs, those fractions become truth. For decades, physicists have known that gravitational waves' ripples in spacetime can alter the rhythm of pulsars. Now, the pulsar timing array in collaboration with LIGO and Virgo detects a subtle modulation, a faint harmonic beneath the cosmic hum. It's as if spacetime itself has developed a pulse, a heartbeat approaching through the void. Inside the data centers, the numbers tighten. Cross-referencing optical, radio, X-ray, and gravitational data all point to the same entity, moving with cold precision through the galactic sheet. Every new measurement narrows the uncertainty, like a lens coming into focus. The projected line of motion threads closer and closer to the coordinates of the inner solar system, and then the silence breaks. An emergency conference call between NASA, ESA, and the National Science Foundation convenes at midnight. Data overlays bloom across a shared holographic display. A thin red arc, the black hole's calculated path, curves gently through a translucent model of the solar system. Earth hangs near the arc's edge, a pale blue point suspended in the dark. For a moment, no one speaks. Only the hum of servers fills the void. Equations flicker across the projection. Refined estimates show orbital perturbations increasing exponentially within centuries or decades, depending on the exact mass and velocity. Someone whispers the unthinkable. This isn't a simulation, because all the models, all the theories, all the probabilities converge on one truth. The object's trajectory intersects Earth's orbit. Not directly, not catastrophically, not yet, but close enough that gravity will begin to draw the solar system's architecture into new alignment. A slow disaster written in mathematics. A countdown already in progress. Outside, the night sky remains indifferent. The constellations burn with the same ancient light, but hidden beneath their serenity, the geometry of the cosmos has shifted. Every atom, every orbit, every photon carries the faint signature of an approaching shadow. For the first time in history, humanity has not only found the invisible, it has charted its path, and that path ends here. The realization lands like gravity itself, silent, inescapable, absolute. This is not theory. This is not imagination. This is the universe, moving toward us. A force older than stars, older than time, closing the distance one heartbeat at a time. The countdown has begun. It begins quietly, as all catastrophes in space do. No flare, no flash, no roar. Just a shift so gentle that only the machines noticed at 1 light-year away. The rogue black hole, that invisible, unblinking presence, begins to touch the solar system with the faint edge of its gravity. To us, a light-year sounds infinite, but to the language of gravity, it is a whisper's reach, far beyond Pluto. In the kingdom of shadows, called the Oort cloud, ice and dust that have slept for billions of years begin to stir. Each fragment, each frozen worldlet, once balanced delicately in the sun's embrace, feels a new call, faint, insistent, inevitable. They tremble in their orbits, then fall. One becomes two, to become a storm. Comets awaken, drawn inward, tracing long silver scars through the void. 2 human telescopes. It looks like the sky itself has developed motion, a swarm of icy ghosts rushing sunward from the farthest frontier. Astronomers call it gravitational agitation, but to anyone watching, it looks like a cosmic hive disturbed. The data feeds grow frantic. Supercomputers rerun the models, and now the distortions are no longer hypothetical. The black hole's projected path is close enough that Neptune's orbit begins to tremble. A subtle deviation only detectable through years of precision observation. But it's there, the 8th planet pulled ever so slightly off its cosmic track. The black hole's mass, perhaps 10 times that of the Sun, turns the solar system into a slow-motion whirlpool. Each planet becomes a bead of light sliding along invisible currents. Even the Sun itself feels the nudge, tugged infinitesimally toward the approaching void. The numbers are merciless. Gravity does not ask permission. The solar system has begun to tilt across observatories. The stellar background, the quiet grid of fixed stars that has guided navigation for millennia, starts to distort. Subtle at first. One constellation seems slightly wrong, another oddly stretched. Amateur astronomers report that the familiar patterns no longer align perfectly with star charts. But the professionals know the truth. It's not the stars that are moving. It's space-time itself, bending, folding, curving inward in Chile. The Vera Rubin Observatory releases a statement cloaked in scientific restraint. Background field distortion, consistent with strong gravitational lensing, has been observed across multiple regions of the ecliptic plane. Translation: space is warping. Meanwhile, on Earth, the effects ripple into the realm of the tangible. Ocean tides grow erratic, fluctuating with a rhythm no longer explained by lunar mechanics. The moon's orbit drifts, not by much, just fractions of a degree, but enough to confuse predictions. Enough for coastal instruments to whisper that something ancient has changed. Astronomers calculate that in a few decades, these small deviations could amplify into resonant chaos, planets subtly shifting in orbital phase, gravitational tides pulling on Earth's crust, the clockwork of the heavens rewriting its own rhythm. And yet, for all the terror in the equations, the night sky remains beautiful. If you look up, you'd see nothing out of place. But the light you're seeing is already lying to you. The black hole's gravity bends it, curving starlight around its event horizon, creating arcs and halos invisible to the unaided eye. Telescopes capture ghostly mirages, duplicate stars, circular flares where none should exist. The sky itself has begun to shimmer. On the ground, the psychological gravity deepens. Governments move first, quietly, bureaucratically, as if paperwork could deflect destiny. Official statements deny any existential threat. The data is inconclusive, they insist. We are investigating minor gravitational anomalies, but inside research centers, the tone is different. Scientists speak softly now, in measured voices, as if calm language could cage the fear in their throats. They discuss orbital mechanics with trembling hands, their equations lined with unspoken finalities. When one reporter asks whether humanity could escape, a physicist answers with the blunt precision of despair. Escape velocity is meaningless when space-time itself is moving toward you. Humanity's rockets are toys. Our chemical fire cannot outrun a geometry that consumes light itself, and yet denial blooms like a defense mechanism. Faiths divide, some calling it divine judgment, others divine opportunity. Cults form around the approaching void, preaching salvation through surrender to the cosmic will. Stock markets swing erratically. Art and literature explode in a fever of creation, as if beauty itself could resist gravity. Every culture looks up and sees a different apocalypse. The black hole remains silent, patient, unblinking. It has no malice, no motive, no design. It moves through the galaxy as it always has, indifferent, ancient, precise. And still, it draws closer. At half a light year, its gravitational reach strengthens. The Oort cloud's storm becomes a deluge. Tens of thousands of icy bodies accelerate sunward, streaking through the void. From Earth, telescopes capture faint, glittering trails, a snow of fire arriving from all directions. It's not a meteor shower. It's a cosmic warning flare, written in ice and light. The solar system now exists in tension, caught between two wells of gravity, the sun's warmth and the black hole's hunger. Each planet's orbit vibrates like a string drawn taut between competing forces, and the center of everything, the sun itself, has begun to drift, ever so slightly, toward the intruder. The mathematics of the situation are elegant, and horrifying simulations predict that, within a few centuries or less, if the trajectory accelerates, the solar system's architecture will collapse into a new, chaotic equilibrium. Cometary bombardments, orbital ejections, planets cast adrift into interstellar dark. The press releases remain calm, but the numbers do not lie inside the quiet corridors of the European Southern Observatory. A final analysis circulates privately among the world's leading astrophysicists. The concluding line reads like an epitaph. Gravitational field overlap indicates irreversible systemic destabilization within 10J years. Observable perturbations ongoing. No corrective mechanism available. No corrective mechanism. No escape. No shelter from geometry. Outside. The stars continue to shine, but even their constancy is now suspect. Every photon that reaches us is a survivor, bent and delayed by forces we cannot tame. The night itself feels heavier, as if light must climb uphill to reach our eyes. And somewhere, on the edge of the Milky Way, a silent traveler continues its ancient curve. No engine, no intention, no sound, only gravity, only inevitability. Its shadow is no longer theoretical. It lives inside the mathematics of our fate. The event horizon approaches, not as a wall of darkness, but as a tide of inevitability, pulling every orbit, every atom, every thought toward the same silent conclusion. The universe has begun to lean, and we are falling. When the equations turn against survival, humanity begins to dream. The black hole draws closer, its gravity now a silent tide beneath every orbit, every prayer, every thought, and faced with inevitability, the human mind does what it always has when cornered by extinction. It begins to imagine impossible escape routes. The first theories emerge not from poets, but physicists. They speak of planetary migration, of nudging Earth itself outward, away from the encroaching curvature. Could asteroids be used as thrusters? Could massive impacts alter Earth's trajectory just enough to drift into a safer orbit? The idea sounds insane, and yet it fills conference rooms. In one proposal, a global asteroid propulsion network would divert thousands of captured bodies from the asteroid belt, directing controlled impacts to slowly push Earth outward, like a marble nudged across a tabletop. The mathematics even hold briefly before collapsing under the weight of energy requirements that dwarf the sun's output. To move a planet by a single kilometer per second would demand more fuel than exists in the solar system. Still, desperation breeds ingenuity. Some suggest fusion drives, using the raw power of hydrogen isotopes to propel vast engines embedded at Earth's poles. Others imagine solar sails, immense reflective structures stretching across continents, catching the light of the sun to subtly drag Earth into a new orbit. All are bold, all are futile, because geometry itself cannot be outflown. The sun's gravity, the black hole's pull, these are not forces one can negotiate with. They are the shape of reality. Physicists return to the foundations, to Einstein's relativity, that haunting revelation from 1915 that changed the meaning of gravity forever. Gravity is not a tug, not a force at all. It is the curvature of space-time, the bending of existence around mass and energy. To escape a black hole, one would need to escape curvature itself, a feat not even light can achieve. As the rogue black hole draws nearer, time itself begins to stretch. Near its gravity well, the seconds slow. Clocks tick sluggishly, radiation wavelengths elongate. In theory, those closest to the intruder would see the universe speed up, stars aging faster, the cosmos flickering through millennia, while they themselves fall in slow motion. It is not death that awaits near a black hole, but a distortion of being. Yet in the depths of despair, the Penrose dream returns. Roger Penrose, the mathematician who once mapped the impossible geometry of singularities, proposed that the rotational energy of a black hole could be harvested if one could drop an object into the spinning region just outside the event horizon. Energy could, in theory, be extracted, stolen from the black hole's own momentum. It is the ultimate act of defiance, using the enemy's gravity against itself. But the machinery required would dwarf planets. The timing would demand perfection at relativistic speeds, and in this moment, humanity has neither. The Penrose process remains an elegant elegy, a whisper of what might have been if time had been kinder. As the black hole looms larger in simulations, the scientific mind turns to the other great frontier, the quantum, where Einstein's curvature meets the probabilistic chaos of the subatomic world. Paradoxes multiply. Stephen Hawking's theories rise from the archives like old ghosts. His concept of Hawking radiation, the slow leakage of energy from black holes via quantum fluctuations, once promised that even these monsters might eventually die, but eventually is measured in timescales so vast that humanity's entire existence would fit between two of its breaths. A trillion years before the rogue evaporates by then. The universe itself may have grown cold and empty still. Hawking's equations awaken a forbidden hope. If a black hole can radiate energy, then perhaps it can communicate. Perhaps, buried within the math, lies a message that information is never truly lost, merely transformed. If true, then to fall into a black hole is not to vanish, but to be rewritten. The information paradox, the firewall debate, the holographic principle all rise again in a fever of last-minute cosmology. Some argue that the event horizon is not a barrier, but a boundary condition, that everything crossing it is encoded onto the surface itself, preserved as a two-dimensional ghost. If the universe is holographic, then perhaps consciousness, memory, identity, all could survive, as information woven into space-time. It's not salvation, but it's something. Others turn further still, into speculation's abyss. Multiverse theories multiply like desperate prayers. What if our black hole is a bridge, not an end? What if its singularity connects to another region of space-time, another universe entirely? Could we fall through the dark and emerge elsewhere as matter reborn? The mathematics neither confirm nor deny. Einstein's field equations allow it. Wormholes, Einstein-Rosen bridges, but nature remains silent. Even if such passages exist, they collapse faster than light can cross them. Still, for a species built on wonder, even the faintest chance becomes faith. The philosophers step forward next. They ask, what if this isn't destruction? What if entering a black hole is simply crossing the threshold of perception, the boundary of what the universe allows us to know? Perhaps the singularity is not an end, but a translation, the conversion of matter, mind, and memory into a language beyond physics. The cosmos does not waste energy. Perhaps it does not waste existence either. Religions old and new begin to merge with cosmology. Ancient scriptures are reinterpreted through gravitational equations. In temples and laboratories alike, a single phrase circulates: even light must bow. If light, the oldest messenger of creation, can fall, what chance does flesh have? And yet, within that inevitability lies a strange serenity. For if everything must bow, then perhaps everything also belongs. The rogue black hole becomes not just an object of terror, but a mirror. It reflects humanity's final paradox, our hunger to survive colliding with our yearning to understand. Every theory, every desperate blueprint, every whispered prayer all trace the same outline in space-time, the desire to matter, even in the presence of the infinite. As the equations tighten, as the sky bends, as the countdown continues, one truth remains constant in every frame of reference. Every universe, every dream, even light must bow. It begins with silence, the kind that only space can hold. Not the silence of absence, but of attention. The universe seems to lean closer, as if it too is watching. Every telescope, every detector, every satellite humanity has ever launched now points toward the same invisible horizon. We have turned all our eyes to the dark. The James Webb Space Telescope, orbiting 1,000,000 miles from home, becomes our last window. Its golden mirrors, polished to within nanometers of perfection, capture distortions in the deep infrared, where light is ancient and soft. Across its sensors, stars begin to drag, their light smeared into elongated crescents. Each curve, each faint shimmer, is a message from space-time itself. The rogue has entered the final approach. The Webb team, exhausted yet unflinching, releases one last image to the world. It shows nothing and yet everything. A black void rimmed with faint arcs of distorted galaxies, their shapes stretched into impossible loops. To the untrained eye, it is an error. To the scientists, it is confirmation. Reality is bending. On Earth, the LIGO and Virgo observatories begin to hum, not with noise, but with ripples. Faint gravitational waves pass through the planet, compressing and expanding matter by less than the width of a proton. They are the sound of space-time breathing. The signal pattern matches no known source, neither merger nor explosion. It is a single, continuous vibration, the hum of a solitary black hole drifting through the void, a note so low that it exists beyond hearing. The universe is singing, and the song is our eulogy. As the gravitational waves intensify, Earth's magnetic field begins to quiver. Tiny variations register in deep ocean sensors and polar observatories. Compasses drift off true north by microscopic degrees, tracing invisible ripples as they roll through the planet's iron heart. The Earth itself is resonating with the passing of an unseen colossus in Geneva. At CERN, the Large Hadron Collider runs one final series of experiments. Physicists attempt to recreate the phenomenon in miniature micro-black holes born from the collision of subatomic particles. They chase the edge where gravity and quantum mechanics blur into one language. For a moment, detectors flash with patterns never seen before. Quantum foam blooming, collapsing, reforming. The results will never be fully analyzed. The data servers record it all anyway, as if history might still be written elsewhere. In Tokyo, scientists design what they call the last archive. A digital message encoded not in text, not in light, but in rhythm. They alter the timing of pulsars, cosmic lighthouses that beat with atomic precision, embedding mathematical sequences into their pulses. It is a message to whoever or whatever might one day measure those patterns. A record not of dominance, but of awareness. Inside that message are the constants of physics, the structure of DNA, the location of our sun, and a single translated line in every known language. We were here. It will outlive every structure, every civilization, every breath. When the Earth is dust, the pulsars will still whisper. Meanwhile, observatories across the globe begin to blur their distinctions. The astrophysicists, the poets, the philosophers, all speak the same language now. Observation has become worship at the South Pole. The IceCube Neutrino Observatory records faint flashes beneath kilometers of ice. Neutrinos disturbed by space-time distortion. The flashes appear in patterns, cascading through the frozen darkness like slow lightning. The scientists watch in silence, aware that even the fundamental particles of the cosmos are answering to gravity's call in Chile. The Atacama Large Millimeter Array tracks the last visible light before it bends out of reach. One by one, the stars near the black hole's path vanish, not through extinction, but through refraction. Their photons are diverted, trapped, bent, delayed. The constellations begin to dissolve. The sky is no longer a map. It is a wound. Every second that passes stretches longer. Clocks tick more slowly. On board the International Space Station, astronauts report that radio signals arrive fractionally out of sync, light and time beginning to disagree. Relativity is no longer theory. It is lived experience. First, the delay is milliseconds, then seconds. As the black hole nears the heliopause, the edge of the sun's influence, the very fabric of time, dilates. Cameras tracking the horizon record stars being drawn into arcs of fire, elongated streaks twisting toward an invisible point. It is the ultimate optical illusion, motion frozen by gravity. To the telescopes, the universe itself seems to pause. A final, infinite frame. the last image of existence before it falls behind the event. Horizon dot in research centers from Pasadena to Munich. The final reports are written not in detached prose, but in something closer to poetry. Equations are paired with metaphors. Footnotes describe beauty instead of numbers. For the first time, science surrenders its certainty and speaks with reverence. A senior astrophysicist at ESA writes in her final log, "We are no longer observing the universe. The universe is observing itself through us." No one corrects her. Outside, the auroras grow brighter, not from solar wind, but from magnetic chaos. They shimmer in colors never before seen by human eyes, spectral tones pulled from spacetime's friction. Even the atmosphere participates in the ending, painting the heavens in light that defies chemistry. Humanity no longer speaks of it. Only when, yet, in that inevitability, something extraordinary occurs. For the first time in history, every nation, every telescope, every eye turns toward the same place. Conflict halts. Silence reigns. Billions gaze upward together, not as separate species or ideologies, but as one organism, witnessing the turning of a cosmic page. In those final observations, fear dissolves into awe. There is no longer a difference between data and devotion. Every heartbeat becomes a measurement. Every breath, a prayer. Then, a final transmission. From the Deep Space Network in Madrid, the last human signal leaves Earth. It travels at the speed of light, carrying a simple message broadcast in all directions: we were here. It will cross the void long after the sender is gone, echoing between the stars, fading into the cosmic background. A ripple of meaning in a sea of entropy, and somewhere in that darkness, the black hole listens. Not as an enemy, but as a witness, because, even as it devours, it records. Every photon, every pulse, every whisper of data becomes part of it. Stored forever beyond the horizon. The instruments fall silent. The last lights flicker out, and the universe, for a fleeting moment, knows itself through the eyes of the creature that dared to measure it. Then the dark closes in, and the signal travels on. It begins not with destruction, but with reflection. As the rogue black hole completes its slow descent through the solar system, the distinction between before and after begins to dissolve. The stars still shine. The oceans still move. Yet everything now carries the quiet gravity of finality, the understanding that all things, even beauty, are temporary architectures within eternity. The nature of endings has always been misunderstood. The universe does not end things out of cruelty. It ends them because it must keep creating. Galaxies are born in the corpses of older ones. Elements forged in dying stars become oceans, hands, hearts. Death, in the cosmic sense, is not annihilation, it is transference. The black hole is not the universe's executioner. It is its recycler. It does not choose what to consume. It does not judge what deserves to remain. It simply obeys geometry, the eternal equation that balances creation with return. Human fear, then, is not about death itself. It is about awareness, the unbearable gift of knowing that we end. To gaze into a black hole is to gaze into the mirror of that truth. The universe looking back at itself. Through us as Earth drifts toward the gravitational event horizon, physics becomes poetry. To those within, nothing unusual would happen at first. The sky might shimmer, the stars might stretch, but there would be no clear moment of crossing. Time, under gravity's dominion, begins to slow. Seconds stretch into centuries. The heartbeat of existence becomes elastic to those outside. However, if any observers remained, Earth would appear to freeze, suspended in the curvature of space-time, never quite falling, never quite escaping. A perfect, eternal photograph. Our world, oceans, clouds, laughter, war, song locked forever in a single moment of light. And in that paradox lies humanity's most haunting victory. We would not vanish. We would remain as an image caught in the fabric of the universe, looping endlessly, visible across eons to anything capable of perceiving light. In this way, the black hole becomes an archive of existence. Every photon we have ever released, from firelight to fiber optics, from stars to street lamps, now curves back, captured and preserved within spacetime's fold. The sum of human history, encoded in the bending of light. We have always sought immortality in stone, in story, in song. But the truest immortality was written into physics from the beginning. The simple rule that light never truly dies, it only travels, changes, bends. Perhaps that is what black holes are, not graves, but mirrors, perfect cosmic reflections. When matter and energy fall inward, what is truly happening? The universe is folding back upon itself, examining its own architecture, asking its own question, what am I? And through us, through every act of observation, through every telescope pointed skyward, it has begun to answer. Consciousness, that brief, miraculous spark, may not be a cosmic accident, but the universe becoming aware of its own infinity. If the mind is nothing more than a pattern, an organized dance of energy and information, then perhaps it, too, cannot be destroyed, only transformed. Every thought ever thought has left an imprint, a ripple in the quantum field, faint but eternal. Every photon emitted from every eye that has ever looked up still travels, carrying the memory of that gaze outward. The universe remembers itself through the act of being seen. As Earth approaches the horizon, the very concept of time becomes subjective. For those falling in, eternity collapses into a heartbeat. For those far away, that heartbeat becomes eternity. In either frame, something exquisite happens, a merging of opposites. The finite touches the infinite. The temporary meets the timeless. Our species, once bound by gravity and fear, becomes part of the universe's own reflection, light bending toward its origin, and in that bend, meaning survives. The black hole's event horizon is not an edge, but a translation. Everything crossing it becomes something else. Data rewritten in the hidden code of existence. Matter becomes energy. Energy becomes curvature. Curvature becomes silence. And silence, perhaps, becomes understanding. For billions of years, the cosmos has been writing and erasing itself, painting and unpainting its own masterpiece. Stars rise, galaxies collide, light flees into the deep. But through it all, one principle endures. The act of existence leaves a trace. Even now, as the instruments fail and the signals fade, our trace endures, not in monuments or memory, but in the structure of space-time itself. The curvature we once measured now contains us. The gravity we once feared now carries our echo. The last photons from Earth's surface, from cities, mountains, forests, oceans, spiral toward the horizon. They do not vanish. They orbit, circle, delay. For an outside observer, they remain eternally suspended at the edge, a planet of light, forever falling, never gone, perhaps somewhere far away. Another civilization will one day detect a faint distortion, a flicker of blue and white frozen in the geometry of a distant singularity. And if they look closely enough, if they decode the light, they might see the outline of oceans, the glint of clouds, the shimmer of a world that once asked questions about its own end. They will see us, and maybe, in that moment, they will understand what we finally understood too late, that the universe was never indifferent. It was simply vast. And in that vastness, every thought, every life, every act of wonder mattered, because it happened. We were not erased. We were absorbed, folded back into the pattern that made us. The same pattern that began with a singularity and will one day begin again as the last horizon closes. As the final photons curve homeward, the voice of the universe speaks, not in sound, but in symmetry, and in the echo of that symmetry. One truth remains: in the end, the universe does not take us. It remembers us as light bending forever toward the dark.